the most powerful tool I use not only in my daily life, but also in, as you have seen in my previous videos and games, is low-level mathematics. What I mean by low-level mathematics is multiplication, division, subtraction, and addition. Yet, I have seen this problem. It has been introduced to me by people who would absolutely destroy me in the higher levels of mathematics. These guys have learned more than twice as much mathematics than I did, which is honestly very impressive of them. However, they have failed at this. And you guys looking at this or at the thumbnail will have figured out that this is, well, let's say 1 for some of you or 9 for some others. So let's talk about why this is such an important thing to understand and how some people who are clearly above the level of these 4 operations, or at least here are 3 of the 4, can fail at this. So let's start first with explaining what low-level mathematics even is. And yes, I'm using the most generic example imaginable. So let's start with addition. I think all of you know what the result of this is, right? If we grab 3 apples from one tree, 2 apples from another tree, we get 5 apples in total. But think about for a moment what this means. The apples on the trees don't change, neither how many of them you grab. The real world, outside of your pieces of paper or calculators, doesn't care how you write these things down. Objective reality has no mercy on us. It doesn't care what we think. This is very hard for people to understand. People were always, especially in social relationships, always in this sort of perpetual state of where they think what they express or how they describe things matters. It doesn't. I can call a house a tree. That will not change the world. The house will not turn into a tree because I called it like that. You can do this with people. Sure, you can, I guess, force someone or into thinking something else about themselves. You cannot really do that with physical objects. They have no perception of our languages. Or more precisely, we are talking here about notation. Now come the more difficult ones. The ones you learn a little later in school. And those are multiplication and division. Let's talk first about multiplication. And what is, in my opinion, one of the root causes for issues. So how would you write multiplication? I, in school, have learned this. Some people, especially in the Western world on lower levels, learn this, which is pretty bad in my opinion because it can be confused with x. And some people use the same thing the computers use. This is a little more difficult to write. It's called an asterisk. This is generally what most computer languages, especially the big ones like C, Java, and so on, use for multiplication. it's still the same operation. The result is still 6, since we are grabbing 3 apples once, and then grabbing 3 apples again, and adding them together. We still get 6 apples. Irrelevant of how we write this. It doesn't matter how we write this. It matters that we just understand what this is. And this, in my opinion, is one of the problems. Same for division. You can write division like this. You can write division a little more efficiently like this. Or you can write division how computers do it, like this, like the example above. We still get the number that multiplied by 2 equals 3. So this is the inverse of multiplication. In this case, 1.5. This is a little more complicated to understand because we are using decimal numbers or fractions, but I don't have any doubts that all of you watching this video have learned those. Where your education system probably failed you, at least in the case for the guys I know that failed this task here, is they have never been taught this concept properly. I almost call myself lucky, and I will, in a certain moment of time, exposed to all of these things, where I had to deal with people writing things down differently. So let's do another interesting example. Let's do 8 divided by 3. This is 2.666, but that doesn't matter for now. Let's write it down differently. A lot of people have learned something like this. 8 divided by 3. This is completely correct. It's just writing it as a fraction vertically. However, what many of them have not learned is, or at least we've not been properly taught or practiced in, is when we do something like this. We use brackets. All this means is the operation inside these brackets is executed first. So first we do 2 plus 1, and then we do the division. However, for some very sad reason, which I have no idea why, people often do this. Which is still correct, don't get me wrong. However, this, especially beyond like the 7th or 8th grade, becomes basically mandatory in school. You are expected to write it down like this every time. Even though your problem is actually written in words or is derived from the real world. What people often forget that this effectively deleted the 2 brackets here. So this is not just writing down division as I have shown you before, with 8 divided by 3, but it also removes the brackets. And this starts to become one of the root causes of problems with this. When we go to the other issue, it becomes even more obvious how this is basically a combination of 2 problems. Have you seen this? I'm sure you did. 2 times x can be written as 2x. It also can be written, however, as this. This is still the same value. Nothing has changed. We are just writing it in the different order. And as you know, with multiplication, you can swap order. This is simply x times 2. This is an important line to understand. People often aren't exposed to this part of it. They often fail at this because they have never seen this and struggle with comprehending the fact that someone can just write something differently. But it doesn't make it incorrect. Our understanding of mathematics is much more robust than you probably think, especially in these notation parts of it. So, what does this problem I'm still not solving do? It does 6 divided by 2 times brackets 2 plus 1. Is this easier for you? If not, let's go one level deeper. 6 divided by 2, and we just do the operation in the brackets, so we get the result of 3. If you are still struggling with this part, this is another problem. When I have searched this online, I have found these even articles about this exact problem, where people are struggling to understand this. However, calculators can solve it, no problem. Because they understand this notation on a more fundamental level than most people. Apparently, there have been some examples in the 20th century that have failed at this, which is very sad, and that's why I recommend you to learn operations without using a calculator first. Here in this Wikipedia article, we can see there are some very sad ways people have learned this. These, I don't know how to say it, combinations of first letters or first letter acronyms. Every time I hear this, I cringe a little bit because it's a really dangerous way to learn things because it doesn't give you the full picture. Thankfully, even these ones can explain you what is going on. First, we always do, let's say when we have an example like this, 8 times 4 plus 5. We first do the multiplication, or if in case this would be division, we would still do first the division. And then we would add 5 to it. So this would be 8 divided by 4 plus 5. What people fail at is when you have divisions and multiplications after each other. I don't understand why, because at least I hope that you were taught that these ones are equivalent. And what do you do when you have equivalent operations? Let's say we have 8 plus 4 minus 5. You simply solve them from left to right. At least in most languages. I'm not saying this is universal for every single language, but please, even if you are using some of the other languages, just learn this. You do here first 8 plus 4, which is 12, minus 5 is 7. That's how simple this is. So why can't you do it here? I don't know. But I suspect that people have just never been used to not seeing something crazy like this instead. Here, you would first do this and then this, because as we have shown in the previous example, you effectively force the brackets here by doing this notation. However, not here. Here we do first the division, 6 divided by 2, which is 3. And then we multiply it by 3. And we get the correct result, which is 9. I have already spoiled it by showing you this in calculators. And as you can see, Even this calculator with steps figures this out properly. Look what it does. It still does it the vertical fraction, but it understands that only the 2 is at the bottom of the fraction, and then it's multiplied by 2 plus 1, which is also a correct way to solve this. Sadly, Wolfram doesn't exactly give us... Wait, maybe it gives us step-by-step solution. This is even funnier. I really hope I taught you something today, and if not, it's even better. At the end of the day, it's better that you haven't learned anything from this video than if you have learned something, because it means you were taught this properly. My suspicion is that most teachers often teach in a very comfortable way for them. If they are by any chance exposed by a child using a different notation, they will not tell them. And listen here carefully. You have two options. They will not tell you, this is a different notation, but we don't use that here. It is correct, but please use this one. They will tell you something more akin to, that is completely wrong. You have written it incorrectly. Use this. Can you grasp the difference between these two sentences? It massively matters for the person on the receiving end. And this example is showing that. The amount of people who are failing this is exactly showing the outcome of this horrific teaching method. When you just tell people something is wrong, even though it is correct. And it probably has some other issues, like gaslighting them. But, well, I'm not a psychologist. And also, the second problem is the massive enforcement of some other things like the vertical fractions. If you are forced to write and solve maths only on a piece of paper, and someone also forces you to write things like fractions in this slightly different way, which has the unexpected effect of the brackets all the time for many, many years. And that's why I suspect the people who have paradoxically learned more math than me have more issues with this, because they have been exposed to this method for much longer, thereby having a greater chance to forget what it actually means. It's very difficult when you are learning something to put yourself above the concept of what you are learning, especially when you go through some of the more difficult schools and they basically don't give you any chance to do that because they just flood you with so much stuff you have to do that you don't have a moment to think about what you are actually doing. So yeah, I hope this helped you. If you are any of the guys that have shown this to me and got this incorrect, I'm sorry, but look into this a little more. And I think this is a little better further to the west, or if we look at people who are paradoxically a little less educated. Because if you look at the results from a poll I made on my Discord, most people, like the vast majority, got this correct. So yeah, there is hope for society. And have a nice day.